Settle into the sleepy mind channel. Tonight we are traveling to one of the most remote and carefully protected places on Earth. Hidden deep inside a frozen mountain, far above the Arctic Circle, more than 1 million seed samples rest quietly behind thick steel doors in complete darkness. They come from nearly every corner of the world and represent thousands of years of farming, exploration, and human history. Each tiny seed carries the genetic instructions needed to grow crops that have fed civilizations for countless generations. Wheat from the Middle East, rice from Asia, corn from the Americas, beans from Africa, and thousands of other varieties all lie side by side inside a vault that was never intended to be opened very often. It was not built to store food for today, nor was it designed as a shelter for people during a catastrophe. Instead, it serves as one of humanity's greatest insurance policies, preserving the remarkable diversity of the plants that sustain life on Earth. If disease, war, natural disasters, or climate change were ever to destroy important seed collections elsewhere in the world, the seeds resting quietly inside this frozen mountain could help restore them. It is an extraordinary idea, yet before we can understand why the global seed vault was built, we first need to understand the remarkable place chosen to protect it. If you enjoy videos like these, feel free to like and subscribe. More videos are posted weekly, and if you would like even more relaxing stories after this one, be sure to explore the playlists here on the Sleepy Mind channel. You'll find peaceful sleep stories covering ancient civilizations, remarkable places, fascinating wildlife, science, geology, history, astronomy, and many other subjects, all designed for relaxing all-night listening while learning something new. Now, let your mind drift northward, far beyond the forests of mainland Norway, across the Norwegian Sea, and into the Arctic Ocean, where a small group of islands has quietly become one of the most important places on our planet. Nearly 800 miles, or about 1,300 kilometers, from the North Pole lies the Norwegian archipelago of Svalbard. It is one of the northernmost permanently inhabited places on Earth, a land of rugged mountains, enormous glaciers, frozen fjords, and vast stretches of untouched Arctic wilderness. Only about 2,500 to 3,000 people live here year-round, with most calling the small town of Longyearbyen home. At first glance, it hardly seems like the place where the future of the world's agriculture would be protected. The landscape appears harsh and unforgiving. Snow blankets the mountains for much of the year. Temperatures remain well below freezing throughout the long winter, and the sea ice once isolated these islands for months at a time. Yet it is precisely these extreme conditions that made Svalbard the ideal location for one of the most ambitious preservation projects ever attempted. Life in Svalbard follows rhythms unlike almost anywhere else on Earth. During the winter months, the sun disappears below the horizon for weeks, creating the long season known as the polar night. Even at midday, the landscape remains cloaked in twilight or complete darkness. On clear nights, however, the sky often comes alive with one of nature's most beautiful displays. Curtains of green, violet, and pale white light ripple silently overhead as the aurora borealis dances across the Arctic sky. The northern lights have fascinated travelers for centuries, and Svalbard is considered one of the finest places in the world to witness them because the dark winter skies last for months. Then, almost as suddenly as the darkness arrived, it begins to fade. Spring returns, and by late April, the sun no longer sets. For roughly 4 months, daylight continues around the clock. Midnight arrives, yet the mountains remain bathed in golden sunlight, as though afternoon has simply refused to end. Residents gradually adjust to sleeping with blackout curtains, while visitors often lose all sense of time beneath the endless Arctic sky. Although only a few thousand people live in Svalbard, wildlife is abundant across the archipelago. Polar bears roam the sea ice and coastlines, and throughout much of the region there are believed to be more polar bears than permanent human residents. Arctic foxes travel across the tundra, searching for food, while the hardy Svalbard reindeer graze on the sparse vegetation that survives the brief Arctic summer. Millions of seabirds nest on towering coastal cliffs, filling the air with their calls during the warmer months before migrating south once winter returns. The surrounding waters support seals, walruses, and even whales that pass through the fjords during different seasons. It is a landscape where nature still dominates, reminding every visitor that humans remain guests in one of the planet's last great wildernesses. Svalbard's history is every bit as unusual as its geography. Although Norway governs the islands today, the archipelago has long welcomed people from many nations under the terms of the Svalbard Treaty of 1920. That international agreement recognizes Norwegian sovereignty while allowing citizens and companies from many participating countries to live and work there under certain conditions. During much of the 20th century, coal mining became the primary industry. Norwegian mining communities expanded around Longyearbyen, while the Soviet Union established its own settlements elsewhere on the islands. The Russian mining town of Barentsburg remains inhabited today, while another Soviet settlement, Pyramiden, was largely abandoned during the late 1990s. Its empty apartment buildings, theatre, school, and mining equipment still stand beneath the Arctic sky, creating one of the world's most remarkable ghost towns. Walking through its quiet streets feels almost as though time itself has paused, preserving a small piece of the Cold War in frozen silence. Living this far north also means adapting to circumstances unfamiliar to most of the world. Because Longyearbyen does not have the facilities of a large mainland hospital, expectant mothers typically travel to mainland Norway several weeks before their babies are due. Another story often repeated about Svalbard is that it is illegal to die there. The reality is slightly different, but just as fascinating. The permanently frozen ground, known as permafrost, prevents bodies from decomposing normally, so Longyearbyen has not accepted new traditional burials for many decades. People who become seriously ill are often transferred to mainland Norway for specialized medical care, and those who pass away are generally buried there instead. These unusual practices are not laws designed to forbid life's natural events. They are practical responses to living in one of the coldest inhabited places on Earth, where the frozen landscape influences nearly every aspect of daily life. To many people, Svalbard might seem like one of the last places anyone would choose to build an international scientific project. It is isolated, cold, expensive to reach, and surrounded by Arctic wilderness. Yet to a group of scientists, engineers, and agricultural experts searching for the safest possible home for the world's most valuable collection of seeds, these islands offered something almost no other location could provide. The mountain chosen for the global seed vault remained naturally frozen year after year because of the surrounding permafrost. It stood high above sea level, reducing the risk of flooding. Norway offered political stability, dependable infrastructure, and a long history of international cooperation. If humanity was going to build a place capable of protecting the genetic future of its food crops for generations yet to come, few places on Earth could match what Svalbard already provided naturally. Before the first tunnel was carved into the mountain, however, another story had already been unfolding for more than 12,000 years. A story that began with the very first farmers learning that the smallest seed could shape the future of civilization. Long before frozen mountains, steel vaults, or international agreements, the future of civilization depended upon a much simpler decision. Somewhere in the valleys of the ancient Fertile Crescent, roughly 12,000 years ago, small groups of people began noticing that certain wild grasses produced larger seeds than others. Some plants survived dry seasons more successfully. Others resisted insects or disease. Rather than gathering whatever nature happened to provide each year, these early farmers made careful observations and began saving seeds from their strongest plants. They planted those seeds again the following season, gradually selecting the characteristics they valued most. Without realizing it, they were beginning one of the longest scientific experiments in human history. Every harvest became an opportunity to improve the next. Every saved seed represented knowledge passed quietly from one generation to another. Those early choices would eventually shape nearly every meal humanity has ever eaten. Agriculture did not appear overnight, nor did it emerge in only one place. Different civilizations, separated by vast distances and unaware of one another, slowly learned how to cultivate the plants growing naturally around them. In the Middle East, early farmers domesticated wheat and barley. Across Eastern Asia, communities developed rice cultivation that would eventually feed billions of people. In Central and South America, indigenous peoples transformed a wild grass known as teosinte into the crop we now recognize as corn or maize. Potatoes were first cultivated high in the Andes Mountains, where generations of farmers developed thousands of varieties adapted to different elevations and climates. Beans, squash, millet, sorghum, lentils, chickpeas, and countless other crops each followed their own remarkable journeys from wild plants into dependable sources of food. Every region contributed something unique to humanity's growing agricultural knowledge, and each crop carried with it generations of careful observation, patience, and experience. For thousands of years, seed saving was simply part of everyday life. After each harvest, families carefully selected seeds from their healthiest and most productive plants. These were cleaned, dried, and stored until the following planting season. Over time, crops gradually adapted to the places where they were grown. A variety thriving in the cool mountains of Peru might struggle in the humid valleys of Southeast Asia, while rice flourishing in flooded paddies would fail in the dry grasslands of Africa. As farmers continued selecting the best performing plants year after year, entirely new local varieties emerged. Some matured quickly during short growing seasons. Others tolerated drought, poor soils, salty coastal conditions, or unusually cold temperatures. The remarkable diversity found in agriculture today did not happen by accident. It developed because millions of individual farmers made thoughtful decisions over thousands of years, often without realizing they were preserving valuable genetic traits for future generations. These traditional farming practices created an extraordinary library of genetic diversity. Every variety carried subtle differences hidden within its DNA. One wheat plant might resist a particular fungus. Another might survive unusually harsh winters. A certain bean could thrive despite poor soil, while another produced larger harvests during dry years. Most of these differences remained invisible until conditions changed. A disease might sweep through one region, destroying many crops while leaving a single resistant variety untouched. An unusually hot summer might devastate one harvest, while another adapted strain continued growing normally. These seemingly small genetic differences often determined whether entire communities experienced abundance or hardship. Long before scientists understood genes or chromosomes, farmers had already discovered through experience that preserving many different varieties offered protection against an uncertain future. As civilizations expanded, so too did the movement of seeds. Traders carried crops along ancient caravan routes connecting Asia, Africa, Europe, and later the Americas. Wheat spread beyond its original homeland into countless climates. Rice varieties traveled across continents. Citrus trees crossed oceans. Tomatoes, potatoes, corn, and peppers eventually transformed cuisines around the world after contact between Europe and the Americas. Every journey introduced plants to new environments where farmers continued adapting them to local conditions. New varieties emerged generation after generation, each shaped by climate, geography, culture, and human ingenuity. Agriculture became one of humanity's greatest shared achievements, built not by a single civilization, but through thousands of years of knowledge exchanged across cultures. By the 19th and 20th centuries, agriculture began changing more rapidly than ever before. Advances in plant breeding, mechanization, fertilizers, and irrigation dramatically increased food production across much of the world. These developments helped feed growing populations and reduced hunger in many regions. Yet they also introduced an unexpected challenge. Modern agriculture often favored a smaller number of highly productive crop varieties capable of producing reliable harvests on a large scale. Older local varieties, carefully developed over centuries, gradually disappeared from fields as farmers adopted newer strains. Many traditional seeds survived only in small family gardens or isolated farming communities. Others vanished entirely as changing agricultural practices replaced diversity with uniformity. Scientists eventually realized the consequences of this gradual loss. Every disappearing variety represented unique genetic information that could never be recreated once lost. A forgotten strain of wheat might contain resistance to a future disease. An ancient bean variety could possess the ability to thrive during prolonged drought. A wild relative of modern rice might carry genes allowing it to tolerate rising temperatures. No one could predict which characteristics future generations would need, making every lost variety a permanent reduction in humanity's agricultural possibilities. Preserving crop diversity was no longer simply about honoring history. It had become an investment in the resilience of future food supplies. During the 20th century, countries around the world began establishing seed banks to protect these invaluable collections. Scientists carefully gathered seeds from farms, research stations, and wild landscapes before drying them under controlled conditions and storing them at low temperatures. These collections functioned as living libraries, preserving genetic diversity that might otherwise disappear forever. Each seed bank reflected the crops most important to its own region, whether rice in Asia, wheat in Europe, maize in the Americas, or sorghum across parts of Africa. Together they formed an international network dedicated to safeguarding one of humanity's most essential resources. Yet despite their importance, these collections remained vulnerable. Fires, floods, equipment failures, earthquakes, political instability, and armed conflict all posed risks capable of destroying decades of careful work in a matter of days. That growing awareness led scientists to ask an important question. If every major seed bank maintained its own valuable collection, what would happen if one of those collections was suddenly lost? Could there be a secure backup, safely protected far from conflict, natural disasters, and the uncertainties of a changing world? The answer would eventually take shape inside a frozen mountain on a remote Arctic island. Before the first seed ever arrived there, however, researchers, governments, and international organizations first had to imagine something that had never existed before. A single place where the agricultural heritage of nearly every nation on Earth could be preserved together, not as a replacement for the world's seed banks, but as a quiet safeguard for generations yet to come. The idea of creating a secure global backup for the world's seeds did not emerge from a single conversation or the vision of one individual. Instead, it developed gradually over several decades as scientists, agricultural researchers, and international organizations began recognizing a troubling pattern. Around the world, valuable collections of crop seeds were already being preserved inside national and regional seed banks. These facilities represented years, and often decades, of careful work. Researchers had traveled to remote villages, mountain valleys, isolated islands, and wild landscapes collecting traditional crop varieties before they disappeared forever. Every collection required careful documentation, specialized storage, and constant attention. Yet despite these efforts, every seed bank faced the same uncomfortable reality. No matter how well protected a collection might be, no single building was completely immune to disaster. By the late 20th century, there were hundreds of seed banks operating around the world. Universities maintained research collections. National governments preserved crops important to their own agriculture. International organizations established repositories dedicated to protecting food security on a global scale. Together, they safeguarded an extraordinary range of plants, from familiar crops like wheat, rice, and beans to lesser-known grains, vegetables, and wild relatives that rarely appeared on grocery store shelves. Each institution served its own purpose, yet they all shared a common goal: preserving genetic diversity before it disappeared. The challenge was not creating these collections. The challenge was ensuring they could survive whatever the future might bring. History had already shown how quickly valuable collections could be lost. Museums had burned, libraries had been destroyed during wars, floods, earthquakes, hurricanes, and fires had wiped out scientific collections built over generations. Even something as ordinary as a prolonged power failure could threaten a seed bank if temperatures rose high enough to shorten the life of stored seeds. Political instability presented another risk. A research center carefully maintained for decades could suddenly become inaccessible because of conflict or changing governments. Scientists realized that protecting the world's agricultural heritage required more than preserving seeds in one location. It required preserving copies somewhere else, far removed from local risks. One organization that played an important role in this growing conversation was the Crop Trust, established to help safeguard global crop diversity for future generations. Working alongside the Norwegian government and the Nordic Genetic Resource Centre, often known simply as Nordgen, agricultural experts began exploring an ambitious idea. Instead of replacing existing seed banks, why not create a single international backup facility? Every participating institution could continue caring for its own collection, while also sending duplicate samples to one exceptionally secure location. If disaster ever struck the original collection, those duplicates could be returned, allowing years of scientific work to begin again, rather than disappear forever. Finding the right location quickly became one of the project's most important decisions. Building a vault, capable of preserving seeds for centuries, required far more than constructing thick walls or installing powerful refrigeration systems. Scientists wanted a place where nature itself would provide an additional layer of protection. Even in the unlikely event that electrical systems failed, the surrounding environment should remain cold enough to slow the aging of the stored seeds. They also wanted political stability, reliable transportation, solid geology, and a location unlikely to experience earthquakes, flooding, or other major natural disasters. Few places on Earth satisfied all of those requirements at the same time. Svalbard gradually emerged as an ideal candidate. The archipelago's permafrost offered a naturally frozen environment that had remained stable for thousands of years. Engineers identified a sandstone mountain called Plateauberget near the town of Longyearbyen. The mountain rose well above sea level, reducing concerns about coastal flooding, while its solid rock provided excellent protection for the storage chambers that would eventually be carved deep inside. Although Svalbard was undeniably remote, it remained surprisingly accessible. Longyearbyen already had an airport with regular flights connecting the islands to mainland Norway, making it practical for seed shipments arriving from around the world. Scientists could reach the facility without extraordinary difficulty, yet its isolated location greatly reduced many of the risks associated with more densely populated regions. Norway also brought something equally important to the project: international trust. For generations, the country had developed a reputation for political stability, scientific cooperation, and long-term planning. The Norwegian government agreed not only to host the facility, but also to finance its construction and maintain ownership of the building itself. At the same time, the system was carefully designed so that Norway would not own the seeds stored inside. Instead, each participating institution would retain full ownership of its own deposits, much like valuables stored inside a secure safety deposit box. The vault would simply provide protected storage. Depositors alone could request the return of their own seeds. This arrangement reassured countries that their agricultural heritage would remain entirely under their own control, while benefiting from one of the safest storage locations ever created. Construction of the global seed vault began during the early years of the 21st century. Engineers excavated a tunnel extending hundreds of feet into the mountain before creating 3 separate storage chambers at its deepest point. Although the entrance features modern architecture rising dramatically from the Arctic landscape, much of the facility remains hidden beneath layers of solid rock. Massive steel doors guard the entrance, while reinforced concrete provides additional protection throughout the tunnel. The storage rooms themselves were designed to maintain a temperature of -18 degrees Celsius, the internationally recognized standard for long-term seed preservation. Combined with the naturally cold permafrost surrounding the mountain, these conditions dramatically slow the biological processes that cause seeds to age over time. When the Global Seed Vault officially opened on February 26, 2008, representatives from many nations gathered in Svalbard to celebrate a project unlike any that had come before it. The ceremony marked far more than the completion of a new scientific facility. It represented a remarkable example of international cooperation centered on something every nation shares: the need for reliable food. Countries with very different histories, climates, cultures, and political systems all recognize the importance of preserving the crops upon which humanity depends. Hidden beneath an Arctic mountain, the vault quietly became a symbol of preparation rather than fear, of cooperation rather than competition, and of the simple understanding that protecting the diversity of the world's seeds is ultimately an investment in the future of everyone. Although the Global Seed Vault appears simple from the outside, preserving seeds for decades, and in some cases centuries, requires remarkable attention to detail. A seed may seem lifeless when held in the palm of a hand, but it is anything but inactive. Hidden beneath its protective outer coat is a tiny living embryo containing everything needed to produce a new plant. That embryo continues carrying out extremely slow biological processes even while dormant. Left in warm or humid conditions, those processes gradually consume the seed's stored energy until it eventually loses the ability to germinate. Scientists therefore faced an important challenge. If they hoped to preserve seeds for future generations, they first had to slow time itself, at least from the seed's point of view. The two greatest enemies of long-term seed preservation are heat and moisture. Warm temperatures accelerate the chemical reactions occurring inside every seed, while excess moisture allows biological activity to increase even further. Together, they shorten a seed's lifespan dramatically. The solution, developed through decades of agricultural research, is surprisingly straightforward. Before entering long-term storage, seeds are carefully dried under controlled conditions until their moisture content falls to a level that greatly slows natural aging. Once dried, they are sealed inside specialized moisture-proof packets that prevent water from re-entering. Only after completing these careful preparations are the packets packed into sturdy storage boxes and shipped north to Svalbard. Many people imagine the vault storing enormous sacks filled with grain, but the reality is much more modest. Each deposit usually contains only a few hundred carefully selected seeds from a particular crop variety. The goal is not to stockpile food, but to preserve genetic information. A few hundred healthy wheat seeds are sufficient because, if needed, they can later be planted to produce thousands more. Those plants can then produce millions of additional seeds over successive harvests. In other words, the vault protects the blueprint rather than the finished product. Every small packet contains the potential to restore an entire crop variety that might otherwise disappear forever. When shipments arrive in Svalbard, they are not immediately placed onto storage shelves. Each deposit is first carefully documented and checked against accompanying records to ensure everything matches the information supplied by the depositing institution. Accuracy is essential because every packet represents a specific variety collected from a particular place under carefully recorded conditions. Scientists may one day need to know exactly where a seed originated, what climate it adapted to, or which farming community preserved it for generations. Losing that information would diminish much of the collection's scientific value. Careful record-keeping, therefore, becomes almost as important as preserving the seeds themselves. Once verified, the sealed packets are placed inside durable storage boxes before being transferred into one of the vault's 3 storage chambers. Tall metal shelving lines the rooms from floor to ceiling, creating long rows that resemble the archives of a great library rather than a traditional warehouse. Instead of books, however, every shelf contains thousands of tiny packets representing crops from every inhabited continent. Wheat collected in Central Asia may rest beside rice from Southeast Asia, while beans from Africa share nearby shelves with potatoes originating in the Andes Mountains. Although separated by oceans, languages, and cultures during their long histories, these seeds now quietly rest together beneath an Arctic mountain, united by a common purpose. One of the most remarkable aspects of the Global Seed Vault is its relationship with the institutions that send collections there. The vault does not replace national seed banks, nor does it borrow or exchange their collections. Instead, it functions much like the secure vault of a bank. Each depositor retains complete ownership of every sample. Norway does not own the seeds, the crop trust does not own the seeds, and the scientists operating the facility cannot simply remove packets whenever they wish. Only the institution that originally deposited a collection has the authority to request its return. This simple principle has helped build confidence among participating countries because it guarantees that every nation remains the guardian of its own agricultural heritage. Today, more than 1 million seed samples have been placed inside the Global Seed Vault, making it the largest secure backup collection of crop diversity ever assembled. Those samples represent thousands of different plant species and an astonishing number of individual varieties. Rice alone exists in tens of thousands of distinct forms, each adapted to particular climates, soils, elevations, or farming traditions. Wheat has followed a similarly diverse path, evolving into countless local varieties across Europe, Asia, Africa, and the Middle East. Corn, beans, barley, lentils, sorghum, millet, chickpeas, and many other crops contribute to a collection that reflects thousands of years of human agriculture. Together they form a living archive of knowledge accumulated by generations of farmers, researchers, and plant breeders. Among the most valuable collections are not always the crops people recognize immediately. Scientists place tremendous importance on the wild relatives of modern food plants. These untamed cousins often survive in difficult environments where cultivated crops would struggle. Some tolerate prolonged drought, others resist insects, diseases, poor soils, flooding, or extreme temperatures. Although they may produce smaller harvests than modern agricultural varieties, they often possess genetic traits that breeders can use to strengthen future crops. As climate patterns continue changing across many parts of the world, these wild relatives may become increasingly important. A single gene discovered in an obscure wild grass or bean growing on a remote hillside could one day help protect harvests feeding millions of people. This is why every packet stored inside the mountain represents something far greater than a handful of seeds. It represents options. It represents flexibility. It represents humanity's ability to adapt when conditions change in ways no one can fully predict. Throughout history, agriculture has survived because farmers continually adjusted to new climates, new diseases, and new challenges by selecting the strongest plants available. The global seed vault preserves the raw material needed for that process to continue. Quietly, beneath layers of frozen rock, these tiny seeds wait patiently, carrying within them the possibility that one day, perhaps decades or even centuries from now, they may once again take root in fields around the world and help write the next chapter in the long history of agriculture. As impressive as the global seed vault may be, it was never intended to become the world's only seed bank. In fact, its entire purpose depends upon the existence of hundreds of other collections spread across the globe. National governments, universities, botanical institutions, agricultural research centers, and international organizations all maintain seed banks dedicated to the crops most important within their own regions. These facilities are where scientists actively study, regenerate, and distribute seeds for research and agriculture. The vault in Svalbard serves a very different role. It remains quietly in the background, functioning as a secure backup that is rarely opened and hopefully seldom needed. Much like making a copy of an irreplaceable family photograph and storing it somewhere safe, the global seed vault exists so that if the original is ever lost, it can be restored. To understand why duplicate collections matter, imagine a library that holds the only remaining copy of thousands of rare books. Even with the greatest care, accidents remain possible. A fire, flood, earthquake, or armed conflict could destroy a collection that had taken generations to assemble. Seed banks face similar risks. Many are located in regions vulnerable to hurricanes, earthquakes, political unrest, or interruptions to electrical power. Even a mechanical failure in a cooling system could eventually threaten seeds stored at carefully controlled temperatures. By maintaining duplicate collections in Svalbard, scientists reduce the likelihood that decades of work could disappear because of a single unforeseen event. Unfortunately, history has already demonstrated that such concerns are far from theoretical. Throughout the 20th and 21st centuries, wars and natural disasters have repeatedly interrupted scientific research around the world. Agricultural collections have occasionally been damaged or placed at risk because of circumstances entirely beyond the control of the people caring for them. These events reinforce the idea that preserving crop diversity requires planning for possibilities that everyone hopes will never occur. The Global Seed Vault was designed precisely for those rare moments when preparation becomes essential. One of the clearest demonstrations of the vault's importance came only a few years after it opened. In the early years of the 21st century, the International Center for Agricultural Research in the Dry Areas, commonly known as ICARDA, operated one of the world's most important seed banks near the city of Aleppo in Syria. Its scientists had spent decades collecting crop varieties adapted to dry climates across the Middle East, North Africa, and Central Asia. These collections contained valuable strains of wheat, barley, lentils, chickpeas, and other crops capable of surviving conditions that would challenge many modern varieties. When conflict spread across Syria, continuing normal operations became increasingly difficult. Eventually, access to the research center was disrupted, placing years of careful scientific work in jeopardy. Fortunately, before those events unfolded, duplicate copies of many of ICARDA's seed collections had already been deposited inside the global seed vault in Svalbard. For the first time since the vault opened, a depositor requested the return of stored seeds. Carefully selected packets were removed from the Arctic shelves and sent to new research facilities in Lebanon and Morocco, where scientists began growing fresh plants and rebuilding the collection. This moment represented far more than the movement of a few boxes of seeds. It demonstrated that the entire system functioned exactly as its designers had intended. The vault was not simply a symbolic project or an architectural achievement hidden beneath Arctic rock. It had become an active safeguard capable of restoring invaluable agricultural collections when disaster made that necessary. Once the regenerated crops produced fresh seeds, duplicate samples were again deposited in Svalbard, completing the cycle and ensuring that future backup collections remained secure. The Syrian experience also reminded the world that preserving crop diversity is not only about preparing for distant future disasters. Sometimes the need arises much sooner than anyone expects. Political instability, unexpected conflict, severe weather, plant diseases, and changing climates can all affect agriculture within a single human lifetime. The Global Seed Vault quietly acknowledges an important reality. While no one can predict exactly what challenges future generations will face, humanity can prepare by protecting as many options as possible today. Among the many crops preserved inside the vault are some that receive little attention, despite feeding millions of people every day. Sorghum, for example, remains one of the world's most important grains in regions where rainfall is limited. Its ability to tolerate heat and drought makes it increasingly valuable as temperatures rise across many agricultural areas. Millet has sustained communities across Africa and Asia for thousands of years, often growing successfully where other grains struggle. Chickpeas and lentils have nourished civilizations since the earliest days of agriculture and continue providing an important source of protein for hundreds of millions of people. These crops may not receive the same public attention as wheat or rice, yet their genetic diversity is every bit as valuable. Scientists are also deeply interested in preserving crops that face growing pressure from disease. Coffee plants, for example, support the livelihoods of millions of farmers around the world, yet many varieties remain vulnerable to fungal diseases capable of spreading rapidly through plantations. Cocoa trees, which produce the beans used to make chocolate, face similar challenges from pests and changing environmental conditions. Bananas present another unusual case because many commercial varieties are propagated without seeds, making the preservation of their wild relatives especially important for future breeding programs. Every crop tells its own story, and every story reinforces the same lesson. Diversity provides resilience. As researchers continue studying plant genetics, they increasingly discover valuable traits hidden within varieties that might once have seemed unremarkable. A forgotten wheat collected decades ago may contain resistance to a newly emerging disease. A wild tomato growing on a rocky hillside could possess genes allowing it to tolerate prolonged drought. An ancient rice variety preserved by generations of farmers might thrive in warmer temperatures than modern commercial strains. These discoveries remind scientists that today's overlooked plants may become tomorrow's essential crops. By preserving as many varieties as possible, the global seed vault quietly protects opportunities that future researchers have not yet imagined. One of the greatest strengths of the global seed vault is that it protects far more than the crops people see every day in supermarkets. While familiar foods such as wheat, rice, corn, potatoes, and beans make up an important portion of the collection, scientists also devote enormous effort to preserving the wild relatives of those crops. These untamed plants often grow in difficult environments where cultivated varieties would struggle to survive. They may flourish on rocky mountainsides, in deserts, along salty coastlines, or in regions where rainfall is unpredictable. To most people they appear ordinary, sometimes even resembling weeds, yet hidden within their DNA are characteristics that plant breeders value tremendously. A wild grass surviving repeated droughts may contain genes that allow future wheat crops to tolerate hotter climates. A distant relative of the modern potato might naturally resist diseases capable of devastating commercial harvests. Preserving these wild plants ensures that future generations of scientists will continue having access to genetic solutions that nature has spent thousands of years developing. Climate change has made this work increasingly important. Farmers throughout history have always adapted to changing weather, but many regions now experience shifts occurring more rapidly than in previous generations. Longer droughts, stronger storms, changing rainfall patterns, and increasing temperatures all place additional pressure on agriculture. Crops that once flourished in certain regions may eventually require new characteristics to remain productive. Plant breeders therefore spend years searching through preserved collections for varieties already possessing useful traits. Rather than attempting to create entirely new plants from the beginning, they often discover that nature has already solved many of these challenges somewhere else. A grain cultivated for centuries in one dry valley may contain exactly the heat tolerance needed to strengthen crops growing thousands of miles away. The global seed vault quietly safeguards those possibilities long before anyone knows they will be needed. Disease presents another challenge that continually reminds scientists why diversity matters. Throughout history, agriculture has occasionally suffered devastating losses when large areas depended too heavily upon only a few varieties of the same crop. Plant diseases spread quickly when every field contains nearly identical genetics. One of the most famous examples occurred during the 19th century with the Irish potato famine, when repeated outbreaks of potato blight destroyed harvests across Ireland. Although many factors contributed to that tragedy, it demonstrated the dangers of relying too heavily upon limited genetic diversity. Similar concerns continue today, with crops ranging from bananas and coffee to wheat and citrus trees. Every preserved variety inside the global seed vault increases the number of options available should future diseases threaten the crops upon which millions of people depend. Bananas provide an especially interesting example because many of the bananas sold around the world are nearly genetically identical. Commercial Cavendish bananas are propagated by cloning rather than growing from seeds, meaning each new plant is essentially a genetic copy of the last. This consistency helps farmers produce predictable harvests, but it also creates vulnerability. If a disease emerges capable of infecting one Cavendish banana plant, it can often spread easily through others because they share the same genetic makeup. Scientists therefore place tremendous importance on preserving wild banana relatives that contain greater genetic diversity. Although these wild species may produce fruit quite different from what shoppers expect, they may hold valuable traits that future breeders can use to protect one of the world's most widely consumed fruits. Coffee tells a similar story. Millions of people begin each morning with a cup of coffee, yet relatively few realize how vulnerable coffee plants can be to disease and changing environmental conditions. Coffee leaf rust, fungal infections, and shifting climates have threatened plantations in several producing countries. Wild coffee species growing naturally in parts of Africa possess characteristics absent from many commercial varieties, making their preservation increasingly valuable. The same pattern repeats throughout agriculture, whether discussing cocoa used for chocolate, grapes grown for vineyards, apples harvested from orchards, or vegetables filling family gardens. Maintaining broad genetic diversity strengthens humanity's ability to respond to whatever challenges the future may bring. Protecting this diversity requires cooperation on an international scale, unlike almost any other scientific endeavor. Every shipment arriving in Svalbard represents trust between nations, research institutions, and agricultural organizations. Countries that may disagree on politics, economics, or international affairs often share a common understanding when it comes to preserving food security. Crop diversity benefits everyone. Diseases do not stop at national borders, and neither do changing climates. A valuable gene discovered in a wheat variety preserved by one country may eventually help improve harvests halfway around the world. The Global Seed Vault quietly demonstrates that some challenges are best addressed through collaboration rather than competition. Visitors are often surprised to learn that the vault itself remains a remarkably quiet place. Unlike museums or research laboratories bustling with daily activity, very few people enter the storage chambers during the course of a year. Deposits typically arrive only a handful of times, carefully scheduled and documented before being placed onto their shelves. Once stored, the seeds simply remain where they are. Scientists do not routinely remove them for study because the original seed banks continue maintaining active working collections elsewhere. The Arctic Vault exists precisely because it does not need constant attention. Its greatest success is measured not by frequent activity, but by long periods during which almost nothing happens at all. In many ways, silence is evidence that the system is functioning exactly as intended. Even routine maintenance inside the facility is approached with extraordinary care. Engineers regularly inspect refrigeration equipment, security systems, and environmental controls while minimizing unnecessary disturbances to the storage areas. Sensors quietly monitor temperature and humidity throughout the chambers, ensuring conditions remain stable year after year. Outside, the frozen mountain continues providing an additional layer of natural protection. Even if mechanical cooling systems were interrupted, the surrounding permafrost would help keep temperatures low for an extended period, buying valuable time for repairs. This combination of engineering and geology is one of the reasons Svalbard was chosen over countless other locations around the world. Nature and technology work together, each supporting the other in preserving one of humanity's most valuable collections. As the number of seed deposits continued growing, the Global Seed Vault gradually became one of the largest collections of crop diversity ever assembled. Every shipment arriving in Svalbard represented years, and sometimes decades, of work carried out by scientists, farmers, botanists, and agricultural researchers around the world. Some collections originated from modern research stations equipped with advanced laboratories, while others contained seeds gathered from remote villages where families had carefully preserved traditional crop varieties for generations. Each packet told a different story. Some represented crops that had fed civilizations for thousands of years, while others contained newly developed varieties bred to improve harvests under changing environmental conditions. Together, they formed a remarkable record of humanity's long relationship with agriculture. One of the most fascinating aspects of the collection is its incredible geographic diversity. A single storage shelf may contain wheat collected from the windswept plains of Central Asia, rice cultivated in the river valleys of Southeast Asia, beans grown high in the Andes Mountains, sorghum adapted to the dry landscapes of Africa, and barley that has survived generations of cold northern winters. Although separated by continents, climates, languages, and cultures throughout their histories, these seeds now rest together beneath one Arctic mountain. Few places on Earth bring together such a wide representation of the world's agricultural heritage in a single location. The numbers themselves are remarkable. More than 1 million seed samples have now been deposited inside the vault, representing thousands of distinct plant species and many tens of thousands of individual crop varieties. Rice alone exists in an astonishing number of forms. Some varieties mature quickly during short growing seasons, while others thrive in flooded fields or tolerate periods of drought. Wheat displays equally impressive diversity, with varieties adapted to cold northern climates, dry deserts, fertile river valleys, and mountainous regions. The same pattern appears throughout nearly every major food crop. What many people casually think of as a single plant often exists in thousands of carefully developed forms, each reflecting generations of adaptation to local conditions. This diversity did not arise by chance. Long before universities established agricultural departments or governments funded scientific research, farmers themselves became skilled plant breeders. Year after year, they observed which plants produced the healthiest harvests, survived difficult weather, resisted insects, or matured at the right time for local growing seasons. Seeds from those successful plants were carefully saved, while weaker varieties gradually disappeared from cultivation. These decisions were rarely recorded in books or scientific journals. Instead, the knowledge passed from parents to children, neighbors to neighbors, and one farming generation to the next. Every traditional seed preserved inside the vault represents not only biological diversity, but also the accumulated experience of countless people whose names history has largely forgotten. Many of those traditional varieties remain especially valuable because they developed under conditions very different from those found in modern industrial agriculture. Some grew without irrigation in regions where rainfall was scarce. Others adapted to rocky soils, steep mountain slopes, or short growing seasons near the limits of cultivation. Certain varieties learned to tolerate occasional flooding, while others flourished despite poor soils that would challenge commercial crops today. As scientists search for ways to strengthen agriculture against future environmental changes, these older varieties often become unexpected sources of valuable genetic traits. A seed collected decades ago from a remote farming community may one day provide exactly the characteristic needed to improve harvests halfway around the world. The importance of preserving agricultural diversity extends beyond simply producing enough food. Crops also shape cultures, traditions, and identities. Around the world, families have prepared familiar meals using local grains, beans, vegetables, and fruits for countless generations. Many traditional dishes depend upon specific crop varieties, selected not only for productivity, but also for flavor, texture, aroma, or cooking qualities. Certain types of rice become perfectly sticky when steamed, while others remain light and separate. Some wheat varieties produce ideal bread, while others are better suited for pasta or pastries. Beans differ in taste, color, size, and the length of time they require to cook. Preserving these varieties also helps preserve culinary traditions that connect people to their history and their communities. Scientists frequently describe crop diversity as a form of biological insurance, but it is also a record of human creativity. Every successful farming society experimented with nature, observing which plants performed best under local conditions and gradually improving them through careful selection. Unlike modern laboratories that may complete experiments within months or years, these agricultural improvements unfolded across centuries. The result was an extraordinary collection of plants uniquely adapted to environments all over the planet. The global seed vault quietly preserves the outcome of those countless experiments, ensuring that future generations will continue benefiting from knowledge accumulated over thousands of years. Perhaps the most remarkable feature of the vault is not its engineering, its location, or even the enormous number of seeds it contains. Its greatest achievement may be something much simpler. It represents a rare example of nations working together to protect a resource that belongs, in one way or another, to everyone. Food has always connected humanity. Every civilization, regardless of language, culture, or geography, has depended upon healthy crops to survive. The seeds resting beneath the mountains of Svalbard remind us that while countries may grow different foods and cultivate different traditions, they all share the same fundamental dependence on agriculture. Preserving that diversity is not merely an investment in science, it is an investment in the future of every community that will one day rely upon the harvests of tomorrow. Despite its reputation as one of the safest places on Earth, the global seed vault has never been viewed as a finished project. It is constantly evolving as new seed collections arrive from around the world and as scientists continue improving the methods used to preserve them. Every year, additional deposits are carefully packaged, documented, and shipped north to Svalbard. Some contain recently developed crop varieties bred to withstand changing climates, while others preserve ancient land races that have been cultivated by farming communities for hundreds or even thousands of years. As agriculture continues changing, the collection grows alongside it, quietly expanding its role as humanity's agricultural backup. One question people often ask is whether every plant can simply be stored as a seed inside the vault. The answer is more complicated than many expect. Most grains, beans, and many vegetables produce what scientists call orthodox seeds. These seeds tolerate drying and freezing remarkably well, making them ideal candidates for long-term storage. However, not every plant follows the same pattern, Certain tropical fruits, including avocados and mangoes, produce seeds that cannot survive being dried to very low moisture levels. Other important crops, such as bananas, are usually propagated through cuttings rather than seeds, while potatoes are commonly grown from tubers. These plants require entirely different preservation methods, including tissue culture, living field collections, or advanced techniques such as cryopreservation using liquid nitrogen. The global seed vault therefore represents one essential part of a much larger international effort to preserve plant diversity. This reminds us that agriculture is far more diverse than most people realize. A grocery store may display only a handful of potato varieties, yet thousands exist around the world. The same is true for apples, beans, rice, wheat, peppers, tomatoes, and many other familiar crops. Commercial farming naturally favors varieties that travel well, store easily, and produce dependable harvests, but countless traditional forms continue surviving in smaller farming communities. Some possess unusual colors, distinctive flavors, or unique nutritional qualities. Others thrive under growing conditions that commercial varieties find challenging. Preserving this diversity means preserving options that future generations may someday find invaluable. Collecting these seeds is often an adventure in itself. Agricultural researchers travel to remote mountain villages, isolated islands, desert communities, dense forests, and high plateaus, searching for crop varieties that may exist nowhere else. Sometimes they work closely with local farmers whose families have cultivated the same seeds for generations. These farmers often possess remarkable knowledge about planting seasons, rainfall patterns, soil conditions, and the characteristics of each variety they grow. A single village may maintain several different strains of the same crop, each selected for a particular purpose. One may mature earlier, another may tolerate drought, while a third produces flour especially suited for traditional recipes. Gathering these seeds preserves not only biological diversity, but also centuries of agricultural experience that might otherwise disappear. Once collected, the seeds rarely travel directly to Svalbard. Instead, they first become part of national or international seed bank collections, where scientists carefully evaluate, clean, document, and test them. Germination tests determine how many seeds remain capable of producing healthy plants. If necessary, researchers grow new plants to produce fresh seed before preparing duplicate samples for long-term storage. Every step follows carefully developed international standards, because preserving seeds for decades requires consistency and precision. Even something as simple as ensuring the correct moisture level before sealing a packet can influence how long the seeds remain viable. Although the global seed vault receives worldwide attention, very little activity actually takes place inside its storage chambers. Deliveries occur only periodically throughout the year, and access remains tightly controlled. Once boxes are placed onto the shelves, they are generally left undisturbed. The seeds require no watering, no sunlight, and no routine care beyond maintaining the proper storage environment. Time passes quietly inside the mountain. Outside, Arctic winters give way to brief summers before darkness returns once more. Snow falls across the mountains, glaciers slowly reshape the landscape, and generations of people come and go in Longyearbyen. Meanwhile, beneath the frozen rock, millions of tiny embryos continue waiting in peaceful dormancy, protected by conditions designed to preserve them for as long as possible. The entrance to the vault has also become an unexpected symbol of hope. Rising from the mountainside is a simple concrete structure crowned by an illuminated work of art that reflects the changing Arctic light. During the long polar night, the installation glows softly against the surrounding darkness, creating a striking landmark visible from across the snowy landscape. It is neither grand nor ornate, yet it quietly announces that something of great importance lies beyond the steel doors. Visitors standing outside often remark on the contrast between the harsh Arctic environment and the hopeful purpose hidden within the mountain. One protects against loss, while the other protects possibility. Although the global seed vault is often described as a place that prepares for the future, it is equally a place that preserves the past. Every packet stored on its shelves represents decisions made by countless generations of farmers who carefully observed the land around them. Long before scientists understood genetics or DNA, these farmers recognized that some plants consistently performed better than others. They selected seeds from crops that survived difficult weather, resisted pests, or produced abundant harvests, then planted those seeds the following season. Year after year, those small decisions gradually transformed wild plants into the crops that now feed much of the world. The vault protects not only the seeds themselves, but also thousands of years of human experience, quietly preserved within their genetic diversity. Many of the oldest crop varieties preserved in seed banks are known as land races. Unlike modern commercial varieties, which are often bred for uniformity, land races developed gradually within specific communities over many generations. They were shaped by local climates, traditional farming practices, and the preferences of the people who cultivated them. A mountain village might develop a wheat that tolerated cold nights and short summers, while a farming community near a river might preserve rice capable of thriving in seasonal floods. These varieties often display far greater genetic diversity than modern commercial crops because they continued adapting naturally to changing conditions over hundreds of years. Scientists consider land races among the most valuable collections in the world because they frequently contain traits that modern agriculture may one day need again. The importance of preserving these traditional crops becomes clearer when considering how dramatically agriculture has changed during the last century. Mechanization, improved transportation, irrigation, fertilizers, and advances in plant breeding have allowed farmers to produce more food than ever before. These achievements have helped support a global population that now exceeds 8 billion people. Yet greater efficiency has also encouraged widespread cultivation of relatively few high-yielding varieties. As those successful commercial crops spread across larger areas, many older local varieties quietly disappeared from fields where they had been grown for centuries. Some survived only because researchers collected samples before they vanished. Others remain alive today because individual families continue planting them in small gardens or isolated farming communities, preserving traditions passed from one generation to the next. Scientists sometimes compare crop diversity to a large toolbox. If every tool inside the box were replaced with identical hammers, many jobs could still be completed, but countless others would become impossible. Agriculture works much the same way. A future challenge may require drought tolerance, resistance to an unfamiliar disease, or the ability to grow successfully in changing climates. Those solutions may already exist somewhere within the enormous diversity preserved by seed banks around the world. The challenge lies in making sure those genetic tools remain available before they are accidentally lost. Every seed stored inside Svalbard helps ensure that humanity's agricultural toolbox remains as complete as possible. One fascinating aspect of the global seed vault is that the vast majority of its collection will probably never be needed. That may sound surprising, but it actually represents success. Scientists hope the duplicate seeds resting beneath the Arctic mountain remain undisturbed for generations, because that would mean the original collections continue thriving in their home institutions around the world. The vault is designed for rare emergencies rather than routine use. Much like a fire extinguisher hanging quietly on a wall, or a lifeboat secured aboard a ship, its greatest achievement may be existing without ever becoming necessary. Yet everyone feels more secure knowing it is there if circumstances unexpectedly change. Even so, the seeds themselves cannot remain in storage forever without attention. Although freezing dramatically slows the aging process, no seed remains viable indefinitely. Different species age at different rates, depending upon their biology. Some grains may remain capable of germinating for many decades under ideal conditions, while others gradually lose viability sooner. Seed banks therefore perform regular germination tests on their active collections. When necessary, scientists plant a portion of the stored seeds, grow healthy new plants, harvest fresh seeds, and return those renewed collections to storage. In this way, the preserved varieties continue their journey from one generation to the next without losing their ability to grow. The process resembles carefully maintaining an heirloom rather than placing it on a shelf and forgetting about it. The frozen chambers of Svalbard therefore represent only one part of an ongoing global partnership. Researchers continue collecting seeds from threatened environments. Plant breeders develop improved varieties for future agriculture. Farmers preserve traditional crops through everyday cultivation, and seed banks carefully monitor the health of their collections. The Global Seed Vault quietly supports all of these efforts by providing a secure final backup should disaster ever interrupt the work taking place elsewhere. Rather than replacing local knowledge or national collections, it strengthens them by offering an additional layer of protection built upon international cooperation. While the Global Seed Vault is often associated with protecting agriculture from future uncertainty, its purpose reaches beyond responding to disasters. It also supports the everyday work of scientists striving to improve the crops that already feed billions of people. Plant breeding is a careful process that often requires many years of observation, experimentation, and patience. Researchers search through thousands of preserved varieties, looking for characteristics that may strengthen modern crops. One variety may produce larger harvests, another may mature more quickly, while a third survives conditions that would damage many commercial plants. By carefully crossing these different varieties, breeders gradually combine desirable traits into new generations of crops better suited to the challenges farmers face today. This work has become increasingly important as growing conditions continue changing in many parts of the world. Some farming regions now experience longer periods of drought than they did only a few decades ago. Others receive heavier rainfall or encounter more frequent heat waves during the growing season. These changing conditions require crops capable of adapting alongside the environment. Scientists therefore spend considerable time studying older seed collections because the solutions they need may already exist within plants developed generations ago. A traditional wheat variety collected from a dry hillside in Central Asia may possess natural heat tolerance that becomes valuable for future farming. Likewise, a bean cultivated for centuries in a mountain valley may survive cooler temperatures that modern varieties cannot tolerate. Every preserved seed expands the number of possibilities available to future plant breeders. One crop that illustrates this process particularly well is wheat. It has been cultivated for thousands of years across an enormous range of climates, stretching from North Africa to Northern Europe and from the Middle East into Central Asia. As a result, thousands of wheat varieties have gradually developed unique characteristics suited to local conditions. Some produce excellent bread flour, while others thrive in dry soils or withstand unusually cold winters. Modern breeders regularly study these older varieties, searching for traits that may improve future harvests without sacrificing quality or productivity. The seeds preserved inside Svalbard quietly safeguard this remarkable library of possibilities. Rice tells a similarly fascinating story. Across Asia alone, farmers have developed tens of thousands of rice varieties over many centuries. Some flourish in flooded fields, others grow successfully on hillsides, and still others tolerate salty coastal soils, where ordinary rice would struggle. Certain varieties mature in only a few months, while others require much longer growing seasons. Preserving this diversity provides future generations with an extraordinary collection of genetic resources capable of responding to changing agricultural needs. Every packet resting on a shelf inside the global seed vault represents one small chapter in the much larger story of humanity's relationship with one of its most important food crops. The same principle extends to nearly every plant preserved within the vault. Corn, barley, lentils, chickpeas, sorghum, millet, peas, beans, tomatoes, peppers, and countless other crops each possess their own remarkable histories of adaptation. Some varieties developed resistance to insects naturally over centuries. Others learned to tolerate poor soils or irregular rainfall. Plant breeders rarely know in advance which particular characteristic will become important years or even decades into the future. By preserving as many varieties as possible today, they ensure that future researchers will have the broadest possible range of options when confronting challenges that have not yet appeared. The Global Seed Vault also reminds us that agriculture has always been an international story. Long before modern transportation connected continents by aircraft, seeds traveled with explorers, merchants, and migrating families. Wheat gradually spread from the Fertile Crescent across Europe and Asia. Rice moved throughout Eastern and Southern Asia before reaching other parts of the world. Corn, potatoes, tomatoes, peppers, and beans crossed the Atlantic after contact between Europe and the Americas, eventually transforming cuisines on every continent. Coffee spread far beyond its African origins, while citrus trees journeyed across oceans to become familiar features of orchards around the world. Every major food crop carries a history of movement, adaptation, and exchange. The shelves inside Svalbard quietly reflect that shared heritage by bringing together seeds whose journeys began thousands of miles apart. Looking toward the future, researchers expect the importance of preserving crop diversity to continue growing. Advances in genetics now allow scientists to study plants with a level of precision unimaginable only a few generations ago. DNA sequencing can identify subtle genetic differences responsible for disease resistance, drought tolerance, or improved nutrition. Yet even the most advanced technology depends upon having diverse plant material available to study in the first place. A gene cannot be discovered if the variety containing it has already disappeared. In that sense, the global seed vault functions not only as a storehouse of seeds, but also as a library of possibilities waiting to be explored by future generations of scientists. As remarkable as the global seed vault is, one of its most impressive qualities is how little attention it asks for. Unlike many scientific facilities filled with researchers, laboratories, and constant activity, the vault spends most of its time in complete silence. There are no daily tours passing through the storage chambers, no busy workrooms where experiments are carried out, and no long rows of scientists studying seeds beneath microscopes. The true work of the vault begins only after the heavy doors close behind each shipment. From that moment forward, its purpose is simply to preserve. The mountain, the permafrost, the carefully controlled temperature, and the sealed storage packets quietly do their work day after day, year after year, with very little human intervention. This stillness often surprises visitors. The entrance to the vault has become one of Svalbard's most recognizable landmarks, yet only a small number of people ever pass beyond the outer security doors. Even fewer enter the storage chambers themselves. Access is carefully controlled, and routine visits are kept to a minimum. Every unnecessary opening of the storage rooms would introduce slightly warmer air, creating small fluctuations in temperature that scientists prefer to avoid. The ideal seed vault is one where very little happens. In this unusual setting, inactivity is not a sign of neglect, but evidence that everything is functioning exactly as planned. Even the surrounding mountain continues playing an active role in preserving the collection. The sandstone of Plateau Berget provides both strength and stability, while the permanently frozen ground surrounding the vault acts as an enormous natural refrigerator. Engineers designed the refrigeration system to maintain the internationally recommended storage temperature of -18 degrees Celsius, but they also wanted the mountain itself to serve as a dependable backup. If electricity were ever interrupted, the surrounding permafrost would help slow any increase in temperature, providing valuable time to restore normal operations. This combination of natural geology and modern engineering makes the global seed vault remarkably resilient. Rather than relying entirely upon technology, it works in partnership with the Arctic environment that surrounds it. The choice of Svalbard also reflects careful long-term thinking in other ways. The entrance to the vault was built well above sea level, reducing the possibility of flooding. The mountain itself offers protection from severe weather while providing a naturally stable foundation for the storage chambers carved deep inside the rock. Although the Arctic climate has warmed in recent decades, the vault has continued adapting to new knowledge. Following an unexpected intrusion of meltwater into the entrance tunnel during an unusually warm period, engineers completed improvements to waterproofing and drainage systems, strengthening the facility even further. Importantly, the water never reached the seed storage chambers, and the collection remained completely safe. The incident demonstrated that responsible stewardship includes learning from changing conditions and making thoughtful improvements whenever necessary. Many people are surprised to learn that the global seed vault is not filled to capacity. Although more than 1 million seed samples have already been deposited, the facility was designed with room for considerably more. The 3 storage chambers together have space to preserve several million additional samples if future collections require it. This generous capacity reflects the understanding that agriculture will continue evolving. New crop varieties will be developed, additional traditional land races will be discovered and preserved, and future generations of researchers may identify plants that today receive little scientific attention. The vault was therefore designed not only for the needs of the present, but also for the possibilities of centuries yet to come. Another remarkable feature of the project is its cost compared with the value it protects. Constructing and maintaining the global seed vault required careful planning and significant investment, yet when compared with the importance of the world's agricultural heritage, the expense becomes surprisingly modest. The crops represented inside the mountain support trillions of dollars in global food production and, far more importantly, provide nourishment for billions of people every day. Protecting the genetic diversity underlying those harvests may be one of the most valuable investments humanity has ever made, even though it consists largely of tiny packets stored quietly on metal shelves. As scientists continue improving their understanding of genetics, the value of these preserved collections is likely to grow rather than diminish. Technologies that once seemed impossible now allow researchers to examine individual genes with extraordinary precision, identifying traits responsible for disease resistance, improved nutrition, tolerance to drought, or adaptation to extreme temperatures. Yet every technological advance depends upon one simple requirement. The plant containing those valuable genes must still exist. A remarkable discovery cannot be made if the variety carrying it has already disappeared. The global seed vault helps ensure that future generations of scientists will continue having access to the extraordinary diversity developed through thousands of years of farming across every inhabited continent. The global seed vault is sometimes called the Doomsday Vault, a nickname that has captured the public imagination since the facility first opened. Newspaper headlines, documentaries, and television programs have often described it as a place that could save humanity after a global catastrophe. While the name is certainly memorable, the scientists who manage the collection generally prefer its official title, the Svalbard Global Seed Vault. Their reasoning is simple. The vault was never built because anyone expected the end of the world. It was built because history has repeatedly shown that smaller disasters happen with surprising regularity. Wars interrupt research, floods damage buildings, earthquakes destroy laboratories, political instability forces scientists to abandon valuable collections. Preparing for these realistic events is far more practical than imagining unlikely apocalyptic scenarios. The vault exists not because humanity expects disaster, but because careful preparation has always been one of civilization's greatest strengths. Perhaps the nickname became so popular because the vault feels almost timeless. Hidden beneath layers of Arctic rock, surrounded by snow, glaciers, and frozen mountains, it seems separated from the hurried pace of the modern world. The seeds resting on its shelves are unaffected by elections, economic changes, or the constant stream of daily news. They remain quietly preserved regardless of what happens beyond the mountain. In many ways, the vault represents one of the few places where people deliberately think not in months or years, but in centuries. Every decision made during its design reflected a willingness to consider people who have not yet been born. That perspective is surprisingly rare in modern life, where so many decisions focus on immediate needs rather than distant generations. The project also reminds us that humanity has always depended upon planning ahead. Thousands of years before written history, farmers saved part of each harvest rather than consuming every available seed. They understood that preserving a portion today meant having something to plant tomorrow. Throughout history, communities stored grain against poor harvests, built irrigation systems that required years of construction, and planted orchards whose trees would not reach full productivity for decades. The Global Seed Vault follows that same tradition on a global scale. Instead of protecting one village or one nation, it protects the agricultural heritage of the entire world. The principle, however, remains exactly the same. Wise preparation allows future generations to face uncertainty with greater confidence. This long-term thinking has become increasingly valuable as scientists continue learning more about the remarkable complexity hidden inside every seed. Advances in genetics now allow researchers to identify individual genes responsible for characteristics that earlier generations could observe but never fully explain. A plant's ability to tolerate drought, resist disease, survive freezing temperatures, or produce more nutritious harvests often depends upon subtle combinations of genetic traits developed gradually over centuries. Each preserved variety therefore represents far more than its outward appearance. Within every seed lies an enormous amount of biological information that future researchers may continue studying for generations. As scientific knowledge expands, collections preserved today may become even more valuable than their original collectors ever imagined. There is also something deeply reassuring about the international cooperation that made the Global Seed Vault possible. In many areas of human affairs, countries compete for resources, technology, or economic advantage. Agriculture presents a different picture. Every nation depends upon healthy crops, reliable harvests, and resilient food systems. Diseases affecting wheat in one region may eventually spread to another. Droughts influencing one continent can affect food supplies around the globe. Because these challenges are shared, preserving crop diversity has become one of the rare scientific efforts where cooperation benefits everyone involved. The shelves inside Svalbard quietly reflect this shared understanding. Seeds collected from nations with different cultures, languages, and histories now rest side by side beneath the same frozen mountain, each contributing to a collection intended to serve all of humanity. Visitors who stand outside the entrance often notice how modest the facility appears. There are no towering buildings stretching across the landscape, no sprawling research campus, and no enormous crowds gathered outside its doors. Apart from the illuminated entrance emerging from the mountainside, much of the vault remains hidden from view. That simplicity is fitting. The greatest treasures preserved there are almost invisible. Each packet contains only a few hundred tiny seeds, easily fitting into the palm of a hand. Yet within those small collections lies the accumulated work of countless generations of farmers, scientists, explorers, and plant breeders. Their value cannot be measured by size alone, but by the opportunities they preserve for the future. As another Arctic winter settles over Svalbard, snow once again blankets the mountains surrounding the vault. The aurora borealis drifts silently across the dark sky, while the people of Longyearbyen continue their daily routines beneath months of polar night. Beyond the town, deep inside the frozen mountain, millions of seeds remain quietly at rest. Wheat that once grew in ancient valleys, rice cultivated beside distant rivers, beans harvested from mountain villages, and countless other crops now share the same peaceful home beneath the Arctic landscape. Together, they preserve one of humanity's oldest achievements and one of its greatest hopes. Long after today's harvests have been gathered and future generations begin planting new fields, these tiny seeds will continue waiting in silence, carrying within them the remarkable story of agriculture and the enduring promise that, with thoughtful preparation, life will always have the chance to begin again. From the outside, the Svalbard Global Seed Vault appears surprisingly modest. Visitors arriving at the site do not find an enormous research campus or a sprawling government complex stretching across the Arctic landscape. Instead, only the entrance is visible. A reinforced concrete structure projects from the mountainside like the opening to a tunnel, its clean geometric lines contrasting sharply with the rugged rock and snow surrounding it. During the long Arctic winter, an illuminated art installation above the entrance reflects light across the ice and darkness, creating a quiet landmark visible from a considerable distance. It is both modern and understated, hinting that something important lies hidden beneath the mountain, without revealing the true scale of what exists beyond the steel doors. The decision to build the vault inside a mountain was far more than an architectural choice. Engineers wanted the surrounding rock to become an active part of the preservation system itself. The storage chambers were excavated deep within the sandstone of Plateauberget, placing hundreds of feet of solid rock between the seeds and the outside world. This natural barrier shields the collection from storms, extreme weather, and rapid temperature changes, while providing remarkable structural stability. Unlike a conventional warehouse built on the surface, the mountain offers protection that no engineered wall alone could easily match. It is one of the reasons the facility has become such a respected example of combining natural geology with modern engineering. Before construction could begin, engineers spent years studying the mountain itself. They examined the strength of the sandstone, the surrounding layers of permafrost, groundwater movement, and long-term geological stability. The goal was not simply to build a secure building, but to create a facility capable of protecting its contents for generations. Every major decision was made with an unusually long perspective. Engineers were not asking whether the structure would remain reliable for 20 or 30 years. They were asking how it might perform a century from now, and even beyond. The completed entrance tunnel extends approximately 120 meters, or nearly 400 feet, into the mountainside before reaching the storage chambers. Walking through the passage creates a gradual transition from the outside world into an environment designed for long-term preservation. The sounds of wind disappear, daylight slowly fades behind each step, thick concrete walls give way to solid Arctic rock, and the temperature gradually drops until the cool mountain air surrounds everything. The journey itself reinforces the purpose of the facility. Every meter deeper into the mountain adds another layer of protection between the priceless collections and the outside environment. At the end of the access tunnel are 3 separate storage chambers. Each room was designed to function independently, allowing the collection to continue growing for many decades into the future. Interestingly, not all 3 chambers are currently filled. Only part of the available storage space is in regular use, leaving significant room for future deposits as additional seed collections are gathered around the world. In total, the facility was designed to accommodate roughly 4.5 million individual seed samples, several times more than are currently stored there. That enormous capacity reflects the understanding that preserving agricultural diversity is an ongoing process rather than a completed project. The shelves lining each chamber resemble those found in a carefully organized archive. Instead of books or historical documents, however, every shelf holds sturdy storage boxes containing sealed packets of seeds. Everything is arranged systematically so that individual collections can be located efficiently if they are ever needed. Despite the immense value of what is stored inside, the rooms themselves are surprisingly simple. There are no elaborate display cases or dramatic lighting effects. The design focuses entirely on reliability, efficiency, and maintaining the stable conditions required for long-term preservation. Every unnecessary feature was deliberately avoided because simplicity often improves long-term dependability. Maintaining the correct environment inside the vault requires a careful balance between natural and engineered systems. Mechanical refrigeration keeps the storage chambers at -18 degrees Celsius, the internationally accepted standard for preserving seeds over long periods. Yet the refrigeration system is only part of the story. Surrounding the chambers is the permanently frozen ground known as permafrost. Even if electrical power were interrupted, the frozen mountain itself would help keep temperatures well below freezing for an extended period. This built-in layer of natural protection is one of the reasons Svalbard was ultimately chosen over many other possible locations. The designers wanted a facility that remained resilient, even if modern technology temporarily failed. Security was also approached differently than many people imagine. The greatest protection does not come from armed guards or elaborate defenses, but from geography itself. Reaching Svalbard already requires traveling to one of the most remote inhabited regions on Earth. From there, the vault sits outside Longyearbyen, surrounded by mountains and Arctic wilderness. Thick steel security doors, reinforced concrete, electronic monitoring systems, and carefully controlled access provide additional protection. But perhaps the greatest safeguard is simply that very few people have any reason to enter. The facility is not a tourist attraction, and routine access to the storage chambers is extremely limited. Most of the time, the vault quietly watches over its collection without interruption, exactly as its designers intended. Perhaps the most remarkable achievement of the Global Seed Vault's design is that it almost disappears into its surroundings. Rather than dominating the Arctic landscape, it becomes part of it. The mountain, the permafrost, the cold climate, and the engineering all work together toward a single purpose. Nothing about the facility feels excessive or extravagant. Instead, every element reflects careful planning, restraint, and a clear understanding that the most successful preservation projects are often the ones that remain unnoticed while quietly doing their job. Hidden beneath the frozen mountains of Svalbard, the world's agricultural heritage continues resting in silence, protected not only by steel and concrete, but also by one of the harshest and most dependable environments on Earth. The environment surrounding the global seed vault is often described as one of its greatest security systems, but it also presents engineers with unique challenges. Building any permanent structure in the high Arctic requires careful planning because the landscape itself is constantly changing. Snow accumulates through much of the year, temperatures can plunge far below freezing, powerful winds sweep across the valleys, and the ground remains locked in permafrost. Every material brought to the site had to withstand conditions that would quickly wear down ordinary buildings elsewhere in the world. Construction crews worked during relatively short Arctic summers, making use of the limited season when transporting heavy equipment and building materials was most practical. Even then, weather frequently dictated the pace of progress, reminding everyone that nature still determined the rules in this remote corner of the planet. One of the most interesting engineering decisions involved something visitors rarely think about: water. At first glance, a frozen mountain might seem like the last place where water would become a concern. Yet engineers understood that even in the Arctic, snow eventually melts, rain occasionally falls, and groundwater slowly moves through layers of rock. Every tunnel carved into a mountain changes how water naturally flows through that landscape. Drainage systems were therefore carefully incorporated into the design from the very beginning, ensuring that moisture would be directed away from the entrance and critical areas of the facility, rather than allowed to accumulate where it might eventually create problems. That careful planning proved especially valuable in 2016, when an unusually warm period caused meltwater to enter part of the entrance tunnel. News reports around the world quickly suggested that climate change had flooded the global seed vault, leading many people to believe the collection itself had been placed in danger. The reality was far less dramatic. The water never reached the storage chambers where the seeds are preserved, and none of the collections were damaged. Nevertheless, the event served as an important reminder that even exceptionally well-designed facilities must continue adapting as environmental conditions change. Rather than treating the incident as a failure, engineers viewed it as an opportunity to make an already resilient facility even stronger. The entrance tunnel was upgraded with improved waterproofing materials, enhanced drainage systems, and modifications that reduce the possibility of future water intrusion. Electrical equipment associated with cooling systems was also relocated farther inside the mountain, providing additional protection. These improvements reflected one of the central philosophies behind the vault itself. Long-term preservation depends not upon assuming every decision will remain perfect forever, but upon continually learning, improving, and preparing for conditions that may not have existed when the project was first conceived. This willingness to adapt has always been part of agriculture itself. Farmers have spent thousands of years responding to changing weather, new pests, unfamiliar diseases, and shifting climates. The global seed vault follows that same tradition. It is not a monument frozen in time, but a living project that continues evolving as scientific understanding improves. The seeds resting beneath the mountain represent resilience, and the vault protecting them reflects that same quality. Its designers never expected the future to remain unchanged. Instead, they built a system capable of responding thoughtfully as new information became available. Another question frequently asked about the vault concerns security. Many people imagine heavily armed guards standing watch around the clock, or sophisticated military defenses protecting the entrance. In reality, the facility relies primarily on layered security rather than dramatic displays of force. The first layer is geography. Simply reaching Svalbard requires traveling hundreds of miles into the Arctic and then continuing to a mountain outside the small community of Longyearbyen. The second layer is the building itself, constructed with reinforced concrete, thick steel security doors, and electronic monitoring systems. Access is tightly controlled, and only authorized personnel may enter the interior. Finally, the storage chambers remain protected behind additional secure barriers, creating multiple levels of security, rather than relying upon any single safeguard. Interestingly, the greatest value stored inside the vault would be difficult for anyone to misuse, even if unauthorized access somehow occurred. The packets contain carefully preserved seeds intended for scientific conservation rather than immediate agricultural use. They are catalogued, documented, and organized according to internationally recognized standards. Without the accompanying records describing their origin, characteristics, and collection history, much of their scientific importance would be lost. The true treasure is therefore not simply the seeds themselves, but the knowledge connected to each one. Protecting that information is every bit as important as protecting the physical collection. The Global Seed Vault also operates under a surprisingly simple principle of ownership. The facility provides secure storage, but it does not own the collections preserved inside. Every country, university, or research institution depositing seeds retains complete ownership of its own samples. The arrangement is often compared to placing valuables inside a safety deposit box at a bank. The bank protects the box, but it does not gain ownership of what is stored within. Likewise, the Norwegian government maintains the facility, while each depositor remains responsible for its own collection. This straightforward system has encouraged participation from countries around the world because it combines exceptional security with respect for national ownership and scientific cooperation. As shipments continue arriving from every continent, the shelves inside the mountain quietly become more representative of the world's agriculture with each passing year. New varieties developed through modern breeding programs take their place beside traditional land races preserved by farming families for generations. Wild relatives collected from remote landscapes join crops that feed millions of people every day. Every new deposit strengthens the collection a little further, expanding the range of possibilities available to future researchers. It is remarkable to consider that somewhere beneath the frozen mountains of Svalbard, a tiny packet added this year may one day provide exactly the genetic characteristic needed to help farmers overcome a challenge that has not yet appeared. That quiet possibility, repeated millions of times across the shelves of the Global Seed Vault, is what makes this Arctic mountain one of the most hopeful places on Earth. Although the Global Seed Vault often receives the greatest public attention, it exists as part of a much larger international network devoted to protecting the world's crop diversity. Across nearly every continent, hundreds of seed banks quietly carry out the day-to-day work that makes the Arctic vault possible. Some specialize in preserving grains such as wheat, barley, and rice. Others focus on vegetables, legumes, forage crops, or the wild relatives of familiar food plants. Universities maintain research collections used by plant breeders, while national agricultural institutes preserve varieties important to their own countries. International organizations oversee collections representing crops that feed millions of people across entire regions of the world. Together, these institutions form one of the largest scientific collaborations ever created, all centered around a surprisingly simple goal: ensuring that no valuable crop variety is ever lost forever. Among the most important of these institutions are the International Gene Banks, supported by the CGIAR, formerly known as the Consultative Group on International Agricultural Research. Spread across several countries, these research centers specialize in crops that are essential to global food security. One center focuses on rice, another on wheat and maize, while others preserve beans, cassava, potatoes, bananas, millet, sorghum, and many additional crops. Scientists working at these facilities constantly evaluate, regenerate, and distribute seeds to researchers and plant breeders around the world. Their collections remain active rather than dormant, with seeds regularly removed for scientific study and agricultural improvement. The Svalbard Global Seed Vault complements this work by preserving duplicate copies that remain safely stored should anything happen to the original collections. The relationship between these seed banks is often compared to backing up important information stored on a computer. Most people keep valuable photographs or documents on their personal devices because they use them frequently. At the same time, many also maintain a secure backup somewhere else in case the original files are accidentally lost. The Global Seed Vault performs a similar role for agriculture. National and international seed banks continue serving farmers and researchers every day, while Svalbard quietly protects duplicate copies that may never need to be touched. If the originals remain safe, the backup simply continues resting beneath the Arctic mountain, ready if it is ever required. One remarkable feature of this global network is the extraordinary variety of people involved. Agricultural scientists certainly play an essential role, but so do botanists, geneticists, conservation biologists, engineers, data specialists, and countless local farmers. In many parts of the world, researchers rely upon farming families who have cultivated traditional crops for generations. These communities often possess knowledge unavailable anywhere else. They understand which varieties thrive during unusually dry years, which mature earliest, which produce the best flour, and which survive difficult local conditions. Their experience helps researchers identify valuable seeds worth preserving long before those varieties disappear from cultivation. Some collecting expeditions have become remarkable adventures in their own right. Scientists have climbed remote mountain ranges searching for ancient barley varieties still grown in isolated villages. Others have crossed deserts to locate drought-tolerant sorghum maintained by farming communities for centuries. Researchers have traveled through tropical forests in search of wild relatives of important food crops, carefully documenting each location before collecting only small samples that allow the original populations to remain healthy. Every expedition reflects the same understanding. Once a rare variety disappears completely, no amount of technology can recreate the exact genetic diversity that evolved naturally over thousands of years. International cooperation has become especially important because crop diversity ignores political borders. A wild wheat relative may grow naturally in several neighboring countries. Traditional rice varieties often spread across regions long before modern national boundaries existed. Rivers, winds, migrating birds, and generations of farmers have all helped plants move across landscapes throughout history. As a result, preserving agricultural diversity requires countries to work together rather than independently. The Svalbard Global Seed Vault quietly symbolizes this cooperation. Nations with different languages, cultures, and political systems all contribute to the same collection because they recognize that protecting the world's food supply benefits everyone. This spirit of collaboration extends to scientific research as well. When plant breeders search for useful traits, they rarely limit themselves to varieties collected within their own country. Instead, they study collections from around the world, looking for characteristics that may strengthen crops grown under entirely different conditions. A drought-resistant bean developed in South America may eventually contribute valuable genetics to breeding programs in Africa. Wheat preserved from Central Asia may help improve harvests in Europe or North America. Rice adapted to one part of Asia may contain characteristics useful in another. Agriculture has always been an international story, and the Global Seed Vault quietly reflects that reality on every shelf within its storage chambers. As the collection continues growing, scientists also continue improving the information stored alongside each seed. Modern databases contain detailed records describing where each variety originated, when it was collected, the conditions under which it grows best, and many of its known characteristics. Increasingly, these records also include genetic information obtained through DNA analysis. This combination of traditional field observations and modern genetics allows researchers to understand crop diversity with a level of detail that earlier generations could scarcely imagine. Yet despite these technological advances, the foundation remains surprisingly simple. Every breakthrough still depends upon preserving the seed itself. Although the Global Seed Vault was created as a scientific facility, it has gradually become something much larger in the public imagination. Every year, journalists, documentary filmmakers, students, and curious travelers make the journey to Svalbard, hoping to understand why a mountain filled with tiny seeds has become one of the world's most recognized symbols of long-term thinking. Unlike many famous landmarks, however, the vault was never designed to impress through size or spectacle. Visitors do not come to admire elaborate architecture or priceless works of art. Instead, they come because the vault represents an idea that is both remarkably simple and surprisingly powerful. It reminds us that some of humanity's greatest achievements are not measured by what we build today, but by what we choose to protect for tomorrow. This long perspective is unusual in a world that often focuses on immediate results. Governments typically plan for years or perhaps decades. Businesses may think in terms of quarterly reports or long-term investments lasting a generation. The Global Seed Vault, by contrast, was designed with a much longer horizon in mind. The people responsible for its creation understood that agriculture has always unfolded across centuries. Many of the crop varieties resting inside the mountain were developed slowly over hundreds of years by farming families who never imagined that their careful work would eventually be preserved in the Arctic. The vault honors that extraordinary patience by ensuring those achievements remain available for generations yet to come. Perhaps the greatest lesson offered by the vault is that diversity itself has value. In everyday life, people often associate efficiency with reducing choices. Growing fewer crop varieties can simplify harvesting, transportation, and marketing, yet nature rarely rewards uniformity over the long term. Forests remain healthy because they contain many different species. Coral reefs thrive because countless organisms depend upon one another. Agricultural systems are no different. The greater the diversity preserved within our crops, the greater the opportunity to adapt when conditions inevitably change. Every additional variety stored inside Svalbard represents another possibility that future scientists and farmers may one day draw upon. This principle becomes especially meaningful when viewed through the history of civilization. Entire societies have risen around successful agriculture. Ancient Egypt flourished because of dependable harvests along the Nile. Early civilizations in Mesopotamia relied upon wheat and barley cultivated in fertile river valleys. Rice shaped the cultures of much of Asia, while corn became central to civilizations throughout the Americas. Every major culture developed alongside plants that gradually became more productive through careful selection and generations of experience. The seeds preserved beneath the mountains of Svalbard therefore represent far more than agriculture alone. They preserve part of the shared story of human civilization itself. It is remarkable to consider how many hands contributed to the collection now resting inside the vault. A wheat variety preserved in Central Asia may have been selected by countless farmers over thousands of growing seasons before researchers eventually collected a sample for a national seed bank. Scientists then carefully documented, tested, dried and packaged the seeds before preparing duplicate samples for shipment to the Arctic. Months later, those same seeds arrived in Svalbard, where they were placed alongside collections from countries the original farmers may never have known existed. Similar journeys have been repeated more than 1 million times. Every packet represents an extraordinary chain of cooperation stretching across generations, continents and cultures. The vault also highlights something easily overlooked in modern agriculture. Every crop growing in today's fields will eventually become part of history. New varieties are constantly being developed as plant breeders respond to changing climates, emerging diseases, and evolving agricultural needs. Some will replace older varieties because they produce larger harvests or tolerate difficult conditions more effectively. Yet even as agriculture moves forward, preserving the crops that came before remains essential. Yesterday's varieties may contain characteristics that tomorrow's breeders unexpectedly need. Progress in agriculture therefore depends not only upon innovation, but also upon careful preservation of what has already been achieved. Visitors sometimes ask whether there will ever come a time when the vault is considered complete. The answer is almost certainly no. Agriculture continues evolving every year. Researchers discover previously unknown wild relatives of familiar crops. Farming communities preserve traditional varieties that scientists have not yet documented. Plant breeders develop improved strains capable of thriving under new environmental conditions. As long as agriculture continues changing, the collection inside Svalbard will continue growing alongside it. The vault was never intended to become a finished archive. Instead, it remains a living project that expands as humanity's agricultural knowledge continues developing. One of the most remarkable aspects of the Svalbard Global Seed Vault is that its success is measured not by how often it is used, but by how rarely its contents are needed. Most scientific facilities exist to conduct experiments, analyze data, or produce new discoveries every day. The vault serves a different purpose entirely. Its greatest achievement is remaining quietly in the background, while the world's farmers continue planting, harvesting, and improving crops without interruption. If decades pass without large numbers of seeds ever leaving the storage chambers, the system is working exactly as intended. The vault was never created to become the center of agriculture. It was built to stand behind it, offering reassurance that should the unexpected occur, the genetic diversity of the world's crops has not been lost. This philosophy has influenced similar conservation efforts in other fields. Around the world, scientists preserve frozen animal embryos, plant tissues, microbial collections, and DNA samples representing thousands of species. Museums carefully protect fossils and archaeological artifacts. Libraries preserve ancient manuscripts under carefully controlled conditions, while digital archives create multiple backups of important historical records. Each project reflects the same understanding that once certain forms of knowledge disappear completely, they may never be recovered. The Global Seed Vault belongs to this larger family of preservation efforts, but its focus is especially fundamental because every civilization depends upon agriculture. Protecting crop diversity ultimately helps protect the food systems that support communities across the entire planet. The seeds resting beneath the Arctic mountain also tell a remarkable story about migration. Human history has always been shaped by movement. Families traveled in search of better farmland. Traders carried unfamiliar crops across deserts and oceans. Explorers introduced plants to continents where they had never grown before. Over many centuries, wheat spread far beyond the Fertile Crescent, rice expanded throughout Asia, corn crossed oceans, potatoes transformed European agriculture, and citrus trees found new homes in distant climates. Every major crop followed its own extraordinary journey, adapting to different soils, weather, and farming traditions along the way. The shelves inside the Global Seed Vault quietly reflect those journeys. Seeds that once traveled thousands of miles through trade, migration, and exploration now rest together in one of the northernmost places on Earth. Many visitors are surprised to discover that the vault contains seeds from nearly every part of the globe, regardless of climate. Tropical countries deposit seeds beside collections originating from high mountain valleys. Crops adapted to hot deserts share storage space with varieties developed near the Arctic Circle. This arrangement highlights an important scientific principle. The value of a seed is not determined by where it is grown today, but by the genetic possibilities it may hold for tomorrow. A drought-tolerant grain preserved in one country may eventually help strengthen crops halfway around the world. Likewise, a disease-resistant bean developed in another region may provide plant breeders with valuable genetic material decades into the future. Agriculture has always advanced through the exchange of ideas, knowledge, and plants, and the Global Seed Vault quietly continues that tradition. The vault has also inspired many people outside the scientific community to think differently about food. Most meals begin with ingredients purchased from a grocery store or harvested from a nearby farm, making it easy to forget the extraordinary history behind every loaf of bread, bowl of rice, or fresh vegetable. Yet every crop people enjoy today represents thousands of years of careful selection by generations of farmers who gradually improved wild plants into reliable sources of nourishment. The Global Seed Vault encourages people to appreciate that long history. It reminds us that agriculture is not simply an industry, but one of humanity's oldest and most important partnerships with the natural world. Education has therefore become an unexpected benefit of the project. Schools around the world now use the Global Seed Vault to teach students about genetics, biodiversity, conservation, geography, and food security. It provides a powerful example of how science, engineering, international cooperation, and environmental stewardship can all work together toward a shared goal. Students learning about the vault often discover that preserving biodiversity is not limited to protecting endangered animals or forests. The diversity found within familiar food crops is equally valuable because it directly supports the future of human civilization. A single seed may appear ordinary, yet within it lies a remarkable combination of biological information shaped by countless generations. The project has also encouraged renewed interest in traditional farming practices. Around the world, many communities continue cultivating heritage crop varieties that have been passed from one generation to the next. These plants often produce unique flavors, colors, or textures while remaining well adapted to local growing conditions. Scientists increasingly recognize that these traditional varieties deserve careful preservation alongside modern agricultural developments. By maintaining both old and new crops, humanity preserves not only its agricultural history, but also a wider range of possibilities for future plant breeding. The Global Seed Vault quietly celebrates that balance, honoring innovation without forgetting the value of the past. As another shipment of carefully prepared seed packets arrives in Svalbard, workers unload the boxes with the same attention given to every previous delivery. Each packet is documented, verified, and placed onto shelves beside collections that may have arrived years earlier from entirely different parts of the world. Once the storage chamber doors close again, silence returns. Outside, Arctic winds continue sweeping across the frozen landscape, glaciers slowly reshape the valleys, and the people of Longyearbyen carry on with daily life beneath the changing seasons. Deep inside the mountain, however, time seems almost to pause. There, surrounded by solid rock and ancient permafrost, the remarkable diversity of the world's crops continues waiting quietly for a future that everyone hopes will be prosperous, but that humanity has wisely prepared for all the same. Although the Svalbard Global Seed Vault has become an international symbol of food security, its true significance is measured not only by the seeds it protects today, but by the opportunities it preserves for centuries to come. No scientist can predict exactly what agriculture will look like 100 or 200 years from now. Crops that dominate fields today may gradually be replaced by improved varieties better suited to changing climates. Entire farming regions may shift as temperatures rise or rainfall patterns evolve. New plant diseases may emerge, while insects expand into areas where they have never been found before. Throughout history, agriculture has continually adapted to changing conditions, and there is every reason to believe that future generations will continue doing the same. The greatest advantage they can inherit is not a single perfect crop, but the widest possible range of genetic diversity from which to build the next generation of plants. Plant breeding has always been a careful balance between preserving successful characteristics and introducing new ones. Farmers first practiced this process thousands of years ago, simply by saving seeds from their healthiest plants. Modern researchers now accomplish similar goals using sophisticated laboratories, DNA analysis, and decades of carefully planned breeding programs. Despite these technological advances, however, the basic principle remains remarkably familiar. Progress begins by choosing from a diverse collection of plants, each offering different strengths. One variety may contribute resistance to disease, another may improve nutritional value, a third may tolerate drought or flooding more effectively. The broader the collection available to researchers, the greater their ability to develop crops capable of meeting future challenges. Nutrition has become another growing area of agricultural research. Producing larger harvests remains important, but scientists also study ways to improve the nutritional quality of the foods people eat every day. Certain varieties naturally contain higher levels of vitamins, minerals, or beneficial plant compounds than others. Some beans provide more protein, while particular grains contain greater amounts of important nutrients. By studying the diversity preserved within global seed collections, researchers continue identifying characteristics that may help improve diets while maintaining reliable harvests. The seeds stored in Svalbard therefore contribute not only to food production, but also to the long-term health of communities around the world. Crop diversity also supports environmental sustainability. Healthy agricultural systems depend upon more than simply producing abundant harvests. Farmers increasingly seek varieties requiring less irrigation, fewer chemical treatments, or greater tolerance to difficult growing conditions. Crops naturally resistant to certain diseases may reduce the need for pesticides. Varieties capable of thriving with less water become increasingly valuable in regions facing prolonged drought. Plants adapted to poorer soils may help farmers maintain productive harvests without relying as heavily on additional fertilizers. Every useful characteristic discovered within preserved seed collections has the potential to make agriculture both more productive and more sustainable for future generations. The Global Seed Vault also serves as a reminder that many of humanity's greatest achievements are built quietly over long periods rather than through dramatic moments. There was no single discovery that suddenly created the remarkable diversity preserved inside the mountain. Instead, millions of individual decisions made by farmers across thousands of years gradually shaped the crops that feed the world today. Every growing season, someone selected the healthiest wheat, the strongest rice, the most productive bean, or the sweetest fruit. Generation after generation, those careful choices accumulated into the extraordinary agricultural heritage now safeguarded beneath the Arctic landscape. The vault honors that patient work by ensuring it will not be forgotten. It is remarkable to think that many of the seeds resting on the shelves today originated in places that appear completely different from Svalbard. Some were collected beneath tropical sunshine, where warm rains fall almost every afternoon. Others grew in dry deserts, fertile river valleys, mountain terraces, or windswept plains. Yet despite their vastly different origins, all now share the same carefully controlled environment inside the frozen mountain. Geography no longer separates them. Instead, they have become part of a single global collection dedicated to preserving the extraordinary diversity that allows agriculture to flourish across every inhabited continent. For the people who live in Longyearbyen, the presence of the global seed vault has become another unique part of life in one of the world's most unusual communities. Visitors arrive throughout the year, hoping to catch a glimpse of the famous entrance, often combining their trip with opportunities to experience the Arctic environment that surrounds it. They may travel by snowmobile across frozen valleys during winter, watch glaciers extending into icy fjords during summer, or look toward the sky in hopes of seeing the shimmering curtains of the aurora borealis. Many leave with a greater appreciation, not only for the vault itself, but also for the remarkable setting that makes its existence possible. Svalbard is no longer known only for coal mining, polar bears, or the midnight sun. It has become a place associated with hope, cooperation, and careful preparation for the future. As the years continue passing, new shipments of seeds will undoubtedly arrive from countries around the world. Additional crop varieties will join the growing collection, while advances in agricultural science will continue revealing new insights hidden within the remarkable diversity already preserved there. Future generations may develop technologies impossible to imagine today, yet they will still depend upon one simple truth that has guided farmers since the dawn of agriculture. Every harvest begins with a seed. By protecting those seeds with patience, care, and international cooperation, the Svalbard Global Seed Vault quietly ensures that one of humanity's oldest traditions will continue growing long into the future, one carefully preserved seed at a time. Perhaps one of the most remarkable aspects of the Svalbard Global Seed Vault is that it asks us to think about time in an entirely different way. Most of our daily decisions are measured in hours, days, or perhaps a few years. We plan vacations months in advance, save for retirement over several decades, and build homes that may last a lifetime. The Global Seed Vault operates on a far longer horizon. Every shipment placed onto its shelves is preserved with the hope that it may remain viable for generations. Some of the seeds stored today may still be capable of germinating long after everyone involved in building the facility has become part of history. Few human projects are designed with such a distant future in mind. This perspective encourages us to appreciate agriculture not simply as an industry, but as one of humanity's greatest continuous achievements. Since the first farmers began saving seeds thousands of years ago, every generation has inherited the work of those who came before. Ancient wheat growers in the Fertile Crescent could never have imagined the modern bread found in bakeries around the world. Early rice farmers tending flooded fields in Asia could not have predicted that their crop would one day feed billions of people across nearly every continent. Indigenous farmers in Central and South America patiently transformed a wild grass into the corn that now grows across vast agricultural landscapes. None of these accomplishments happened quickly. They emerged gradually through observation, experimentation, and countless growing seasons, each building upon the successes of earlier generations. The Global Seed Vault quietly continues that tradition. Rather than preserving monuments or written records, it preserves the living foundation upon which agriculture itself depends. Every seed represents a tiny package of possibility, carrying the instructions needed to produce another generation of plants. If placed into healthy soil with sufficient moisture, warmth, and sunlight, the same seed that rested for decades beneath an Arctic mountain can begin growing once again. Few objects created by nature possess such remarkable potential. They appear almost motionless while in storage, yet inside each one remains the capacity to produce roots, leaves, flowers, and eventually thousands of new seeds of its own. Looking across the collection as a whole, it becomes clear that diversity is the vault's greatest strength. No single crop can feed every climate, every culture, or every landscape. Communities living beside tropical rivers rely upon different plants than those farming dry grasslands or cool mountain valleys. Even within the same country, agricultural needs may vary dramatically from one region to another. Preserving thousands of different varieties ensures that future generations will continue having choices. Some may become important because of changing weather patterns. Others may provide resistance to diseases not yet discovered. Still others may simply preserve flavors, traditions, and farming practices that communities wish to pass along to their children and grandchildren. The story of the Svalbard Global Seed Vault also reminds us that scientific progress often depends upon cooperation. Countries from every inhabited continent have contributed to the collection, placing trust in a shared effort that benefits everyone rather than any single nation alone. Researchers continue exchanging knowledge across international borders. Farmers preserve traditional varieties in local communities, while scientists document and study them. Governments support agricultural research, knowing that discoveries made today may strengthen harvests decades into the future. It is an encouraging example of people working together toward a goal that extends beyond politics, economics, or geography. The preservation of crop diversity has become a shared responsibility because food itself is something every society depends upon. There is also a quiet humility reflected in the vault's purpose. The scientists and engineers who created it readily acknowledge that they cannot predict every challenge future generations will face. They do not know which diseases may emerge, which climates may shift, or which crops may become increasingly important. Rather than pretending to know every answer, they have chosen to preserve as many possibilities as they can. That willingness to prepare without claiming certainty may be one of the project's greatest strengths. It recognizes that nature has always been more complex than any single generation can fully understand. As evening settles once again over Svalbard, the mountains around Longyearbyen fade into the soft Arctic light. In winter, the aurora may drift above the dark sky. In summer, the midnight sun lingers over the frozen valleys long after most of the world has gone quiet. Beyond the town, deep within the sandstone of Platåberget, the seeds remain where they have been placed, sealed in darkness, held by cold rock and Arctic silence. They ask for no attention. They simply rest, carrying their small living promise through the night. Thank you for listening to the Sleepy Mind channel. I hope you enjoyed learning about the Svalbard Global Seed Vault. Until next time, thank you for spending part of your evening here. Have a restful night, sleep well, and we'll see you again on your next journey with the Sleepy Mind channel.